So this week, one of my problems was problem 55, and in problem 55, the physics of circular motion limits human walking speed. As you are walking, your body pivots in circular motion over your forward foot as you bring your rear foot forward. Thus, the normal force of the ground on your foot decreases and your body tries to lift off the ground. In part a person's center of mass is very near the hips at the top of the legs. Model a person as a particle of mass m at the top of the leg length L. Find an expression for the person's maximum walking speed Vmax. And in part B, we are evaluating our expression for the maximum walking speed of a 70 kilogram person with a 70 centimeter leg length, and give your answer in both meters per second and miles per hour. Then comment based on your experience as to whether this is a reasonable result. And for reference, a normal walking speed is about 3 miles per hour. So over here, I've drawn the person as a particle m right here, and then in blue we have the leg length L, and then I've also labeled the angles theta here, and then I've also illustrated the forces. And so here we have normal force on the foot of the person as it is in contact with the ground, and the person, or the particle I guess, also experiences force of gravity, so we have that, and then their velocity, and also velocity. And so over here we have written this equation. It's Newton's second law, which is force equals mass times velocity squared over, usually this is r, but for the sake of this problem, r will be L, which is the leg length, and this is also the expression for the centripetal force when the object moves in a circular path. So just like some more important concepts. So moving on to the actual solution for part A, we just need to find an expression for a person's maximum walking speed. And so we will use this equation, and we get mass times gravity times cosine theta equals mass times velocity squared over L. However, mass cancels out as it is on both sides, and so we get gravity times cosine theta equals velocity squared over L. And we want to rearrange to solve for the velocity, and so when we do that, we get velocity equals the square root of gravity times L times cosine theta. And so an important note here is that because velocity will be at its max when theta is equal to 0 and cosine of 0 is equal to 1, we can essentially not write this part right here because we know it's equal to 1. And so for part A, our answer is V equals the square root of gravity times L. And so in part B, we are applying this formula right here, and we are trying to solve for the maximum walking speed of a person who is 70 kilograms and has 70 centimeter long legs. And so for part B, all we're really going to do is plug in 0.7 meters. This is equivalent to 70 centimeters for L, and then for gravity, obviously 9.8 meters per second squared, and we're going to plug it into the equation we solved for in part A. And when we do this, in this step right here, we get 2.6 meters per second. But for part B, we need to also include the answer in miles per hour. And so here, with this conversion unit, we convert meters per second to miles per hour, and we get 5.8 miles per hour. And so for part B, the maximum walking speed of this person is 2.6 meters per second and 5.8 miles per hour.